Hello everyone, and in this video we're going to be talking about completing the square. You don't really need to worry about where the name completing the square comes from because it's beyond what we need to actually understand for GCSE and A-level. However, it is a really useful technique because it helps us to find the coordinates of the turning point of a quadratic. And it's really useful when solving lots of problems, both at GCSE and in particular A-level. So I'm going to start off at the beginning and go through to more complicated ones. So the way it starts, when we're talking about completing the square, a question usually will not ask you to complete the square. What it will usually say, a question will usually say, write this quadratic in this form. Sometimes they change the letters and they might use P and Q, but often they use A and B. They could even use R and S. So it doesn't really matter what letters they use. A question would say, write a quadratic in one of those forms, okay? And these are the most straightforward ones. So let's have a look at one. I'm going to do this one here where it says x squared minus 4x plus 1. And I'm just going to show you what we do for the process. So what we do is we first of all start off by halving the coefficient in front of the x. So, and then we put the expression in brackets. So we write x minus 2 squared. So I've put it in brackets. I've halved the coefficient in front of the x, and then you take that away squared. So minus 2 squared plus 1. Now, it's interesting whether or not to know whether or not this is a plus or a minus in here. You always take that away squared, okay? So let's work this out. This is x minus 2 squared minus 4 plus 1. So x minus 2 all squared minus 3 is our answer. And you can see how we've written that in the format that is required. So you can see how it matches that x add a add b kind of format. So that's how we actually do it. Now, some important things to notice. Where do students make mistakes? This is an area where students sometimes make mistakes, this minus 2 squared. Minus 2 squared is minus 4. I think a common error here is that students think about this as being plus 4. But actually, if we wanted it to be positive 4, we would have to have minus 2 in brackets like that, because that would mean minus 2 times minus 2, which would be positive 4. Okay, so that's the first place where some students sometimes make errors. So minus 2 squared means minus 4. So hence, that's why here I took away minus 4. Okay, let's do another one, and then I'll talk to you about how we link this into the coordinates of the turning point. Let's do the one there that's called question 1h. So x squared minus 10x plus 25. So again, we halve that number that's in front of the x. So it's going to be x minus 5 all squared minus 5 squared plus 25. So in this particular one, I've ended up with x minus 5 squared minus 25 plus 25. They're going to cancel, and my x is going to be, my answer is going to be x minus 5 all squared. Now, technically speaking, that one I've picked there is kind of in the required form. You've just got to imagine that the extra term that's added on is a 0, okay? So because we're trying to get them in the form x add a squared add b. It just so happens in that one that I've picked there that the b was a 0. Okay, one more of those, and then we will have a look at, oh, actually, let's do one where we've got one where when we halve it, it gives us a fraction. So I'm going to do the one there that's called P, question 1p, x squared minus 7x minus 2. Okay, so what we're going to do is halve that. So it's going to go to x, and I'm going to write it as a fraction. I know you could write it as a decimal, but I don't know. I think it's, especially when we move up to potentially A-level, thinking about things as a fraction can often be a better way forward. So I've halved it and I've written it as 7 over 2. So I'm going to do minus 7 over 2 all squared, and then there's my minus 2. Okay, so I've now got x minus 7 over 2 all squared minus 49 over 4 minus 2. And then I can work out what that's going to be. So 49 over 4, and then we're going to have minus 2 is going to give me minus 57 over 4. So I have x minus 7 over 2 all squared minus 57 over 4. And that's the way that I would deal with it when we've got a fraction. Okay, we've just literally combined it in the same way that we've been doing before. Now, let's talk now that we know how to complete the square, let's talk about some of the instances of where it's so useful. And you may remember I said a moment ago, it helps us to find the coordinate of the turning point of a quadratic, or the coordinate of, sometimes it's called the vertex, okay? So this point here is sometimes called the vertex, and it's sometimes called the turning point. Now, once we've written the quadratic in completing the square form, the coordinate of the turning point is given by changing the sign of what's in the bracket and leaving the sign of this one the same. So here I've got x minus 7 over 2. So I'm going to change the sign from a minus to a plus. So that is 7 over 2. I've changed it to be positive. This one stays the same. So minus 57 over 2. And that is the coordinate of my turning point. So you change that sign and this one stays the same. So if we were to have a look at this one here, our previous example, x minus 2 squared minus 3, I would change that sign to be a positive. So my turning point would have a coordinate of 2 and minus 3. So I've changed the sign for the one that's in the brackets, and I've kept the other one the same. And that is super useful. And there's lots of questions where being able to do that really helps us out. Let's just look at one more just to do. So let's say we had x plus 11 squared minus, and let's say it was plus 14. Okay, and we wanted to find out the coordinates of the turning point. The coordinates of the turning point would be given by changing the sign of this one, so minus 11, and keeping that one the same. So the coordinate of that turning point would be 11, 14. Now, where this comes to be really useful, both at GCSE and in particular at A-level, is we might have questions where we've got to say, for example, prove that a particular quadratic is never less than 0, for example. And so the reason why completing the square would really help us out there is because we'd be able to see that for this particular turning point, it has a coordinate of the x value is minus 11 and the y value is at 14. So we can see that the lowest value that this particular quadratic is ever going to have is 14. So therefore, we can demonstrate that it never cuts the x-axis. Okay. All right, that's perfect. So there we go. That is completing the square and how it works in the most basic instance. Okay. Let's do one more. We'll do one more of these because we're going to move up in the next video to a slightly more complicated version. We're just starting off with the nice introductory completing the square. Let's do one where we've got a fraction. Let's do s. Okay, so question 1s, we have got x squared plus 2 over 3x plus 1. Okay, now we're going to halve the fraction. So you could do that by doubling the denominator. So I could think about that as x plus 2 over 6, okay, squared minus 2 over 6, all squared plus 1, okay, like that. And then that 2 over 6 is just going to be a third. So we've got 1/3 squared minus 1/3 squared, which is going to be 1 over 9. And then we're going to add 1 to that. And then we're now going to just combine that in order to get our final answer. So that is going to be 8/9 there. So that is going to be plus 8/9. So x plus 1/3 all squared plus 8 over 9. Okay, so I just halved that fraction. I did it by doubling the denominator. I could have just written it as 1/3 straight away if I wished as well. If the question had asked us to write down the coordinate of the turning point or the vertex of that quadratic, then we can see that the coordinate is going to be change that sign, so that would go to -1/3. This one stays the same, so that is going to be 8/9, and that would be the coordinate of that turning point. Okay, well that's our introduction to completing the square. In the next video, we're going to move on to slightly trickier ones where we have a coefficient in front of the x squared. But I will see you in the next video for that one.